And now it's time to get on to installing the motor and turning this into a working chassis. So Bowser provides a DC-71 motor with pretty much all their kits, or provided anyway. And they actually made these using the original Pitman tooling, which I guess they bought sometime in the 70s, maybe the early 80s. So they're good, reliable motors that'll last basically forever. Not quite up to the standards of modern motors, though. You can see in some areas they're built a little bit sloppy. You can see the shaft kind of moving around in the bushing there. But that doesn't really cause any problems aside from maybe a bit of noise. And the first thing that they instruct you to do in the manual is to oil the bearings, so that's exactly what I'm going to do. Just use some of my oil here. This is transmission fluid. Of course, high quality oils from LaBelle and some other companies will also do a great job. Just a couple little drops in the front and then a couple more in the back. I like to use a wire for this. That way I can get a little droplet on the end of the wire and then just carefully touch it to where it needs to go. And then with that oil, it should be a good smooth runner that's ready to go. I'll just power that up real quick. So yeah, as you can hear, there's definitely bearing noise. So I'm going to put a little more oil into that front one. I think that's where it was coming from. Yeah, that helped a bit. It's never going to be perfect though. But this will at least make the model into a good, strong runner. Now to mount the motor, you just need these two screws here. There's this brass one with a larger head, a little bit bigger screw thread, and then the 256 here that's about, well, just about ½ an inch long. They also give you a couple fiber washers for adjusting the gear mesh. So to start out, I'll just use the 256 screw, which goes right here. Sometimes you just kind of have to hunt around a little bit while you're mounting it to get that first screw in, because it's kind of hard to see where the actual hole is sometimes. There, feels like that's tightening in now. Okay, yeah, it's holding in place. And the gear is meshing. So that seems good so far. So now I'll put the rear screw in. Goes right there. It's nice that they have a brass one for this spot, because steel screws tend to get attracted by the magnet. Now I'll have to loosen this one a little to get these lined up. Okay, now it's starting to tighten in. I think that actually loosens the mesh a little bit. You can kind of peek in through the spokes in the wheels, get a good idea of where the gear is at. So I think I'll add one of those fiber washers in here. If the mesh is too tight, then you would add the washer between the motor and the front screw. But if the mesh is a little bit loose, then it goes in the rear screw. Just kind of line that up in there. You can do that with a smaller screwdriver like that. And then put this one back in. That feels a bit better. You don't want much movement in the wheel gear there. If the mesh is too loose, then you could have gear slipping and excess wear on just the tips of the teeth. Of course, if the mesh is too tight, then the edge of the worm here is just kind of going to bind with the inside of the gear. And that'll put a lot of strain on the motor, leading to higher current draw and, again, more wear. So let's power that up real quick. the motor gets its power from the right rail through the frame and the body of the motor. On later kits, there was a second wire which would come out from here, and then you would just attach that to some point of the frame, like maybe to one of the screws here, and that would get it working. Seems to be working well. Mesh feels good and solid. And I'll just switch those connections around, see how it does in reverse. So I wonder if maybe the mesh is a little bit tighter than it should be. Well, I don't know. Seems all right so far. For some reason, this axle feels a little tighter than usual, though. Oh, you know what? I think this screw down here might have put a little extra pressure on this rear axle bearing. I'm going to try loosening that just a tiny bit, see what happens. Yeah, that feels more free. Yeah, that seems better. Yeah, that's a lot better. Okay, so I guess this front screw also tightens down on this plate, and if this plate was sitting flush against the frame, then that wouldn't be a problem, but it's kind of resting up on those axle bearings, so you have to be careful not to tighten that too much in this case. That doesn't happen with every Bowser chassis design, but it seems the tolerance for the for the bottom plate here wasn't quite as good as some of their other kits, so you just have to work with it a little. And once it's tuned right, everything's just fine. As you can see there, it's nice and smooth. Of course, you don't want to run this for long without grease. So I'm going to add a little bit into there. Got my white lithium. Again, companies like LaBelle make some good quality gear grease, specifically for model trains. I just tend to get what's at the readily available at the hardware store, though. Okay, some Bowser kits, they'll have the gear exposed right here, but this one has it covered, so I'm just going to have to kind of shove this into here a little. Run that slowly to start. If you run the motor too fast when you're first putting the grease in, it tends to just fling the grease out all over the place. So this keeps things a little cleaner, to just work it in slowly. In this case, since that gear is a little difficult to access, I'm actually gonna loosen the motor here. Just give myself better access. Lift the motor out of the way. Spread it lightly in there. Just kind of roll that around a little so I can get to different points of the gear. I think that'll be enough. The motor will spread that through. And you only need a thin film of grease over the gear teeth. If you try and go too thick, all it does is fly out, and then it makes a mess of things. Once again, run this slowly. You can see it spreading along the worm. And a little bit of that is gonna kind of fling out, get on the wheels and chassis. So I'm just gonna take this Q-tip here, dab a little bit off. Make sure the wheel treads are clean. That's looking good. Pick up the speed a little. Seems like that's spreading through nicely. And it's not even flinging out all over. I might still find a couple little droplets here and there, but that's easy enough to clean up. Again, run it in the other direction so that it spreads completely. Okay, motor installed, gears greased. So now I just need to get the motor hooked up to the drawbar. And this one uses a wireless drawbar system, which is nice. So just hold the terminal in place on the drawbar screw. Take one of these little nuts here. Start that on there without getting attracted by the magnet. It's a steel nut, so it wants to go that way. And then use a wrench or a nut driver. Just hold that in place. Well, actually hold the screw in place. And then tighten the nut down over it. Okay, now that's connected and in place. And to test that out, hook up one terminal to the drawbar, the other one to the chassis. And that is working just fine. Now I also want to give this chassis a track test. So to do that, I've gotten out the Tinder chassis parts. So that's just the frame there. And then trucks in here. And in this kit, they give you sprung equalized trucks, which is kind of cool. And you can see on this side, there's a big insulator on the wheel, and then this wheel is grounded. Since the right rail is grounded on the engine, it has to be the left rail grounded on the Tinder. Now, the Tinder frame has quite a bit of flash around that, but I'm not going to worry about that for now. I'll clean that up when I actually get to assembling the Tinder. For now, I just want to give this a quick track test. So the truck mounting screws, they have this sort of post built in, and then just a small amount of threading at the end. Very easy to pick out. Drop that into the truck. And tighten that down completely. So on this one, it looks like the Tinder doesn't actually screw to the engine, which is unusual for a Bowser. It just has this sprung contact on the drawbar, which is soldered in place. And that fits down over this tab here, just like that. So it's still a pretty secure system, but it makes it so you can separate them easily. And that's actually pretty nice. Okay, I've got some track on the table. Put the engine on there carefully. Works nice and smoothly. No problems. So in that case, I'm going to take it over to the layout real quick, and we'll see how it does on an actual track. Alright, so it's on the layout, and I actually haven't cleaned the drive wheels yet, so they've got a few decades of tarnish and oxidation, so I won't be surprised if I see a little bit of electrical cutting along the way, but let's see how it does. Actually, that's doing even better than I expected. Whoops. Okay, so the problem wasn't actually the engine, it's the track itself. Seems like it got warped in that spot, and the long wheelbase just doesn't like it. I'll have to fix that track. Well, I found the problem with that spotted track, so temporarily just jammed a screwdriver in there. And now you can see, the chassis makes it over, no problem at all. That long wheelbase is just a bit touchy about these spots, it seems. So that's really all there is to mounting one of these motors in the chassis. Not much at all to it. Very simple process. Easy to get a good smooth runner. Now I have found that with motors that have this bit of sloppiness to their build, they tend to take a lot of oil to keep running quietly. And I kind of want to take things a step further. So now let's see how to install a coreless motor in there. Now this coreless motor that I've picked out, it's quite a bit smaller than the DC71, but the specifications of it are actually very similar for RPM and torque. Now you can see that it is quite a bit smaller, so I'm definitely going to have to come up with a different way of mounting. And to do that, I'm going to take both of these motors over to my computer, and we're going to figure out how to make a mount for it using the 3D modeling program. Now, as long as I've got the motor off, I might as well also go ahead and pull that worm. So I've got my Northwest Shortline puller here. Just lay the worm on the plate, get things lined up. Things may be at a slight angle at first just because of the tight assembly. Get the shafts touching, make sure they're well aligned. Let's see if that works. Take a little Allen wrench and start to slowly press it. I think that's starting to move. See if I can align that better now. Yeah, that helped. Now it's pressing a lot more straight. And that is coming right off, just the way I need. Okay, worm is off. Free from the motor. Looks like they used a little bit of glue to hold it on. Okay, so I have the 3D program open on my computer. This here is Fusion 360. I've learned how to use this at work, so that's why I also use it at home. So we got the DC71 motor here, and I'll replicate that in the program, as well as the coreless motor, so that I can line things up and make a mount for the coreless motor. And for replicating the motors, it really helps to have some calipers on hand for taking all the different measurements so that I can do it as accurately as possible. To show you all how this works, I'm going to start by creating the coreless motor. So I'll just make a quick sketch here. Grab the circle tool. And then let's see, the exact diameter of the motor using the calipers is 17 millimeters. So make a 17 millimeter circle. I want to pull on that. And the length of the motor, 25 millimeters. So that cylinder is actually most of the motor. But in order to make it as accurate as possible, I'll make another sketch on top so that I can make the bearing on the front of it, which has a diameter of 6.1 millimeters. Do that. Finish the sketch again. Pull that out. Do that. And I'll just assume another 1 millimeter there. And then after that is the shaft, which I know is a 2 millimeter shaft. And the length of that shaft, 6.2. So aside from the terminals, that's basically the whole motor. Also get the screw holes on there. Start with the 2 millimeter hole. And then I want to have 6 of those on there. So I'll get a circular pattern going. Center point. Now make that 6. Select all of these, held Control and then clicked each one to do that. Then we'll give those a depth of 3 millimeters. Doesn't really need to be that accurate. But there's the basic coreless motor. There are of course going to be 2 terminals on the back, but I won't be covering those, so I'm not going to bother with modeling them. I just needed the actual motor body in there. So I'll create the DC71 motor the same way. That one's going to be a little more complex though, so I'm going to skip the filming on that one and just show you the results. Okay, so I've got my DC71 model finished. As you can see, I also made the worm over here so that I can work with that because I'll be reusing the original. I'll just bring back the coreless motor, which has its shaft aligned with the DC71. I'm just going to move that into position, back it up to where the back of the DC71 is, and keep it there. So now, see, I've got everything in position, so the next thing will be to make the lower half of the body, that'll be, or the lower half of the mount for the coreless motor. And I'll be using the base of the DC71 as the reference for doing that. Well, after a couple hours of work, I think I finally got a good motor mount put together. You can see here that the coreless motor fits inside the 2 halves. And when I hide the top, you can see how it all fits in there. So the worm fits in the front here, just shaft going through, and then the motor's here. And also left this larger space open for a coupling between the motor and worm. A couple locator tabs. And then on the back there are a couple more small holes which will let me mount a small motor retainer plate, which will also help to hold the 2 halves together. Then down here there's a space for the axle gear, drive gear, mounting holes that match the frame. And I also made it so that these are square areas here which should match up to Athearn bearings. So I'll use one of those at each end of the worm. And there should also be enough room for a washer or 2 to help things work more smoothly. So I'll just make a couple more small tweaks here and there, and then get this design in the printer. See how it turns out. We've got that on the printer now. Things seem to be working well so far. So we'll see how that comes out in a couple hours. As for my printer settings, this can vary depending on your environment, but I found that for me, using this PLA filament, a nozzle temperature of 190 degrees Celsius works well, along with a bed temperature of 50 degrees, and that's on a tempered glass bed. Sometimes it takes a couple tries to get it started very well. This is actually my second attempt. The first one didn't go out quite as well after a few layers, just because sometimes the bed takes a while to really even out its temperature. But once the bed's temperature is evened out, things tend to work a lot better. Well, the print just finished a minute ago. Looks like things came out pretty clean. So I'll just carefully get that off of there and see how that all works. Alright, so there are the parts all printed out, and test fitting that to the chassis. Seems like everything is right as it should be. Hopefully I got the gear mesh right. I think I did, but we'll find out later. The worm will fit right in there, along with the Athearn bearings at each end, which I've got right here. And the motor fits right into there. And for that space there, I was originally going to use a piece of drive tubing to couple the shafts together, but then while I was shopping for some Hobbytown parts, I found out that they have these close coupling kits now, which look pretty nice. So that's just a ball joint that fits to each shaft, and then you use this cup to fit the 2 together. So I'll give this a try and see how it works. Alright, so the first thing I need to do is make sure the worm shaft is cut to length, so I'll just, with the motor in position there, I'll just hold the shaft in place. They'll go almost right up to each other. Then cut it right there. Just mark that with a Sharpie. Then it's easiest to cut shafts like this by using a cutting wheel on a Dremel. I'll do that here. You want to be careful not to hold too close to the cutting area because that gets hot real fast. Right, and then to finish that off, I always just take off any little bit of flash left at the end, and then I roll it against the side like this to give a nice bevel to the edge. That makes it a lot easier to press on anything that needs to fit in place. Now to get the worm onto there, I'm going to have to press that into place, so I'm going to put that into my vise real quick and bring it right back. When you're pressing something like this onto a long shaft, you do have to be careful, because if the shaft or anything goes in at a sort of angle and it's a tight fit, then it's very easy to accidentally bend the shaft, and then when that happens, it's even harder to straighten it out, and at that point you might as well just replace the shaft. So I have it pressed on most of the way now. To start, I just put the end of the worm flat against the inside of the vise and then slowly press the shaft until it stopped. Now to get it the rest of the way, I'll usually take some kind of a metal block or flywheel or something else with about the same hole diameter or slightly larger. So this is a metal pulley I got off of something. And then I'll just put it up against there and then press the shaft on the rest of the way. That allows me to get it through as much as I need. Right, and you can see how I've got things mounted in there. And the shaft has started to press through, so I'll just put that on a little more. Don't want to go too much though. Now we'll see how this looks. And that's just about right. If I need to press it on any more, I can do that pretty easily at this point. I've got the Athearn bearings fit on there, each one with a washer. And just check to see how that all fits in the new mount. Basically no forward and back play, but it spins nice and free. I don't think that could have possibly turned out better, so I'm happy to see that. And the shaft is at just the right length too. So in that case, I'll go ahead and press that ball on. So let's see how things fit together with that new coupling. Slip that on. Put the motor on. One end of that coupling kind of snaps in place, but that is nice and straight. So I'm just going to put the cover on there and power it up real quick, see how it does. You know, this actually kind of reminds me of the old Varney motors back from when Lindsay was doing the design work for them. Needs a little bit of oil to get rid of that noise. I think that's running pretty well. It feels like that vibration noise is coming from the worm. That's not bad though. Oh, now with that all checked, since I know it's working, let's see how the gear mesh is. Maybe just a little bit loose. So in that case, what I can do is I can file down the bottom of the motor mount a little until that mesh is better. Okay, things are coming along. Starting to get some gear mesh. So I'll just do a little more filing, get it a little bit lower, and I think that'll be ready to use. And sometimes it can be hard to get a very even surface with filing, so sometimes it also works just as well to sand it down like this. That way you can keep it as flat as possible on the bottom. I think I've got that well adjusted now. You can see there that the gears are meshing Things are working nice and smooth. So now I'll just add in a touch of oil. See if that helps to quiet things down a little more, get it working smoother, which I'm sure it will. Already sounds quieter. That coreless motor can freewheel even without a flywheel attached. So if it ever loses power, it can actually coast a tiny bit. Of course, the worm's going to lift without the cover on there. If I hold that in place, things are nice and smooth. Well, since everything is adjusted, I think it's about time that I can get the motor assembly here finished. So PLA holds really well to super glue, so I've put a few little drops in a few choice areas around there, just holding it together until everything is set. And I've got the holes in back here so that I can attach a strip to help hold the motor in place, although I might also give it a small droplet of glue in a couple spots to keep it from possibly rotating, because as you can see, it is possible to twist the motor in there. But overall, it's a nice tight fit. This should work really well. All right, the motor assembly is done. I made this back plate using a piece of copper strip, which was really easy to do. All I had to do was just cut it to size and then put a couple holes in it, screw it on. And that's actually holding the motor in so tightly that I won't even need to use glue to hold it centered. Also, comparing the two, you can see that the new motor actually takes up even less room than the old DC71, but it should have just as much torque. So now it's time to get things hooked up. So I'll take the old wire off of the DC71, use that on the new motor. This wire will go on the left terminal. Put a little solder in place. We'll put a little more on the iron. Then I'll just do this. That'll hold. Okay, I've got the negative wire hooked up to the drawbar just like it was before. Then I've also put a second wire onto this brush, and I have it running over to an Atlas terminal, which is connected to that screw there. Now let's see if this thing works. Well, the wheels are a little dirty. Oops, there's a short circuit somewhere. Let's see where that's coming from. Oh. One of the tender trucks turned around when I wasn't looking. Now let's try it. That is working nice and smooth. But that turned out really nice. New motor's got plenty of torque too. One last little thing I did. The original screw for the motor was a bit too short to work with the plastic here, so I replaced that with a longer one to hold things together. So now I'm just gonna clean up the wheels here and then give it some more extensive track testing. Just do that gently with this bright boy block to start. Then I'll finish it off with a buffing wheel. Just a quick look there, you can see the buffing wheel really gives these things a nice shine that other methods just don't quite do. That's why I like to do this on metal wheels, on all metal wheels anyway. It's a little more dangerous to do this on wheels that have plastic centers just because the heat could damage the plastic. When it's all metal like this, pretty much no risk at all. Come out with a real nice shine. Buffing does always leave some dirt behind, so you want to finish off by just wiping the excess off from the wheels. Alright, now let's take this over to the track and see how it does. Take So pretty smooth. There is some noise. I think that might be some vibration of the worm shaft, so I'll just have to tighten that up a little bit. And there's the full speed. Very similar to what it was with the original motor, but just a little slower. I think that'll be a good scale speed for the M1 here. And since I fixed the track, there's no more derailing. So I'm going to continue to give this some testing in both directions around the layout, and I think this will turn out to be a really nice runner. So that's it for installing the motor, as well as doing a modern method of remotoring. And there are, of course, many other ways to do a remotor too, such as just using a metal strip mounted to the frame and then having the motor attached to that with the worm pressed on, so it's essentially the same as a DC71, just a little nicer. And then there have been others in the past, like the Helix Humper motor kits, which still appear now and then. Those have a nice can motor with a flywheel attached. And there are other methods beyond that. But anyway, for the next video, I'll be getting on to assembling the boiler, as well as the main tender body.